Okay, thanks a lot for the warm welcome. And I think we've had like a lot of engaging discussions and everyone is fascinated by generative AI. So are we, and that led us to the research that we did. So I'll sort of just set the context, like what we are trying to do. So like a lot of times, I think what we see is like there's a dependency on coding to generate different kind of data analysis or insights. So what we've attempted to do is democratize the process so that everyone who knows English is able to manipulate data, generate insights, and this can be done for, say, any kind of strategy development or reporting or like any ad hoc work that comes up. So that's the problem that we've started to solve. And from generative AI perspective, from generative AI perspective, now what we're trying to do, the word generate. So that's what we've done, like we're generating codes. So that's the content that we're generating. It's not natural language, but it's more technical. So going into that dimension, that generative AI cannot just say maybe summarize or do a Q&A with English as the output. The output here is more technical, which is SQL queries. And what we'll cover in our presentation today, we'll focus on the data set or the problem statement so that it gives the landscape why it is like a complex problem to be solved. We'll focus on some of the key challenges which are there. Obviously, like it was like an extensive research. We can't deep dive on every aspect given time constraints. And then with those challenges, we'll come out, say, like what is the final architecture created. And on top of it, what we've also done is build an end-to-end conversation BR tool. So that's one where we'll get into, and some enhancements that we see will help in sort of taking it to the next level, and that's what we'll focus on. So just to give it up, like what was the magnitude of the problem statement was and why it became like a complex thing to be solved. So first of all, like what we were working was with over 500 plus variables, 10 plus data sets. Now the data sets were different level, like some of them were aggregated, some were at an account or a customer level. So the level was different across the data sets. There were data sets which had same name but different meanings, or different names and same meaning spread across different data sets. Then there were data sets which were like the same solution could have come from different, like if you ask a question, the answer could come from, say, 3 different data sources. So that's the magnitude of the problem which really made it complex. Like how do you prioritize, how to select, these are the tables that needs to be solved, and then create the SQL query with the right accuracy. And a brief on like what all information we had in these data sets was primarily, these were banking data sets. So like right from like just send out different campaigns, your customer response. So you have their response information. Then you acquire some customers, so you had their acquisition, who got approved, who got declined, the demographics, channel, and all of that. Then the other data sets that we had were on performance. So how the customer is doing, how many of them are delinquent, what are their current balances, and then we had on if there are any complaints and the attrition. So tried again, like there can be a lot of other data sets, like if we talk about banking, but this is what we began our research with. So I think what we'll do is move to like some of the key challenges which we saw, which were the addressed. I'll sort of hand it over to Saket to take that up.
So as you all know, open source LLMs were used in this research, and the major challenge of the open source LLMs is the sensitivity towards the words. Say you are talking about acquisitions, and you want to understand. You want the LLM to understand, are you talking about customer acquisitions? Is it an account acquisition? The business level context, it's completely missing from the LLM. And it will tend to hallucinate if you don't give this information. So identifying the right business context is one of the key challenge. I mean, it is different for different segments, like for banking it's different, for financial institutions it's different. Now, going deeper into the data set, there are variables coming into play. A lot of these variables, like the name of the variable, it can be acquisition 1, acquisition 2, response 1, response 2. All of them talk about the similar things. Now, when a user asks, I want to know how many customers are there across portfolios? Am I talking about acquisition one, or am I talking about response one? What am I talking about? Now, these sort of questions, these sort of challenges are critical in terms of identifying, how can we send that knowledge graph, or how can we send, the right context into the LLM. Now, even going broader, the datasets, right? Datasets have, there are multiple types of datasets. These can be summarized. These can be, granular, the level of granularity. And some of these datasets talk about the same thing. 90% of them is the same. Only the 10% is specific to that dataset. Having the knowledge, having the context of this dataset is also crucial. Now, you have a problem like, say I have an acquisition rate. I want to define this as, X by Y. And I want to give this to my large language model. I want it to perform this calculation. Currently, it's not in the state to perform because it doesn't understand what is X, what is Y. So to incorporate these type of custom calculations is also a crucial challenge that we try to address. And so in addressing this, we developed a robust custom RAG framework, majorly to identify right context, right business context, right variables that the user is gonna ask in the question, as well as right data sets. Now, let's take a simple example of acquisitions, right? What can a user expect from this table? He expects, hey, what are my acquisitions across product or across portfolio or across channel, right? What are the trends, as well as, what is the type of the profile of a particular customer or, in a particular segment. So these type of questions lead to the variables where it targets, like where we have discussed the challenges coming into picture. To solve these challenges, we have incorporated a knowledge graph. Now, if you see the second half of the slide, the variable details, like you kind of have a deeper understanding of what a variable is, both in terms of the name, synonyms, like what can I call acquisitions, customer acquisitions. I can call acquisitions maybe as account level acquisitions. And you describe it, these are the acquisitions from maybe 2021 to 2023, some sort of description that a business is expecting in that variable, as well as variable type. Is it a number? Is it a string? And sample values, a lot of these have been incorporated. Not only the variable level, at also the dataset level, where we describe, the table or the dataset that we are having, majorly in terms of what this table talking about. It's talking, so for example, the acquisition database that we're having. This is a database that talks about acquisitions at customer level split in a monthly fashion. So this sort of detailed description will help the large language model understand the context better and give the right output. Now, we talked about variables, data sets, we talked about giving the business context. There's a crucial factor, like you can't send all this knowledge graph into the large language model because of its limitations. We need to find a way to send only the required amount into it. Now, definitely out there are a lot of methods, like you might be all aware about Pinecone, Llama Index, ChromaDB, vector spaces majorly. But they're not doing a great job. They have maybe an accuracy that is not that we are expecting. So EXL, being in the space of analytics over past 20 to 30 years, we have the knowledge and expertise, and we came up with a custom scorer in terms of finding the similarity. What is the user asking? Is he asking about this variable, or is he asking about some other variable, or is he asking about this right table? Am I arriving at the right table or not? So a depiction of how the scorer works here is told. To brief it, first we find the words inside the question, the user prompt that he's asking, and then we go into identifying the possible variables, identifying the possible databases, and then narrowing down it to one, and then giving this one as like both the business context, the variable context, and the data description of the databases to the RAG framework that we are having. And this is what we call focused knowledge graph. We are focusing on the particular segment, the relevant aspect, and that's where we are trying to minimize the hallucinations, trying to gain more accuracy in terms of our output. This whole thing goes into the RAG framework, and I would like Nikhil to take this up.
Yep. So I think this is what is the interesting part here. Now, this creating of this RAG framework is what becomes the key, because there are multiple vector stores which are already there. But we saw that they were not performing as well, and building a custom scoring algo for your semantic search became really important for us. And which is what you see, like to generate the SQL query, like we've created like a flow, like what really happens. So you see there, like there's a knowledge graph, which is like we've created, say for 500 plus variables, everything is fed into that. Now, what really happens is when the user asks the queries. So the step one that happens is now from that query, like we're mining every word, we're identifying all the variables. And from those variables, we're also identifying the synonyms. So all of that is first, like that is sent to that similarity algo. We identify, say, create different pairs, create a score out of it, and the ones which has the highest score, that is how we pick up the variables in the datasets to come up with the final focused, say your 10, 15, or like whatever that number of variables which are required to a particular set of question. So that's step one that goes into it, which is then sent into the prompt template that we have built. So prompt template, step one, what's happening is we are sending this context, enriching the prompt, making sure the LLM understand the context, what it needs to do. And then through this multi-shot prompt approach, like we are coming up and creating the final prompt through which the SQL query needs to be generated. So that's the overall flow that really went into it. And even after the SQL query is generated, we're seeing some errors. Like for instance, like very simple example of this, now your date variable in each data set was different. Sometimes it takes date time format, sometimes it takes date 9 format. So like LLM even was still not able to understand these kind of things. So even after generating the query, we identified like what is the right format of the variables, and we brought in an error mechanism, correction on top of this, and then the final query is generated. And all this, I think, using open source LLMs, I think we were able to do end-to-end process on an average of around 15 to 16 seconds, where you get the query, which then gets executed to generate the tabular output, and we also have insights and the charts. So this is what is happening to generate the SQL query. And what we'll do is, moving this, like we created an end-to-end framework fed into a conversational BR tool. So which has, you can interact this, the end consumers can interact it using a user interface. So what really happens here is the pre-work, I think what we spoke about all the knowledge graph and the vector stores, this is what is done beforehand, what you see at the bottom of the slide. So we create the knowledge graph based on the user query, the chunking will happen, and we'll get to the right variables. So this is all what is fed into the vector stores. Now, whenever the user comes and asks the query, so before going into the prompt chain, you fed the right information. So before even going to that LLM call to understand like what is the variables, you derive your focused knowledge graph, you enrich your or augment your prompt, and then you create the prompt template which is fed into the LLM. This LLM will then generate the SQL query. So all this is the generative layer that's happening. From here, now we translate this query to where to the data warehouse where all the data sets are sitting. So the data will get, the query which is generated will get queried on the data warehouse. It will sort of connect with the databases. So again, the SQL query which is coming, you need to, like if you want to interact, let's say with the platform, you'll have to provide those IDs and passwords as well. So that's another layer which is added on top of the SQL query. You load the data sets, you generate the output. This output then goes back to the LLM. You generate, it will sort of then recommend the charts. It will generate some textual insights about what is happening with the data. It will give you the patterns of say how, how the variables correlated, or like what kind of relationships you see there. And all of this is then sent to the UI. So on the UI, what user is just giving an English language query. And through that, they're able to get the SQL query, their charts, their insights, and the tabular output. So this is the end-to-end flow of the conversational BI tool, where we've used this ability of the LLMs to generate SQL queries from English language. And I think what we'll do is like the tool, the end-to-end tool that we build. I think some of the things which are there, obviously, you see that you are able to generate tables, insights. But along with that, like obviously the purpose of this is to help, say with, you can automate your reporting, you can do your ad hoc analysis. So the idea is not just SQL query, but like you're also able to create your reports in a manner that you can circulate, let's say, to your leadership teams, your partners. So we've created the charts and the tables which are created. They're like, aesthetically they're good. You can select, say, the color schema or the type of chart that you want. So all of that, so that the report which are created, it seems like more presentable and it can be directly shared as is. So that's there. The other capability is where, again, like the high sensitivity to these language models to English language was, which was an issue for us to fix, and that's something that we solved through more and more synonyms and all. But the way you're posing the question, or the user is posing the question, it's not robotic. So you can throw English questions, like free-flowing, fluid questions, and you're still able to derive the output, which is the key. And so the way, again, I think we covered it, the way we build that is like for a particular variable, there can be multiple ways or multiple terminologies that the organization might be using it. So just to give, I think what Saket was saying earlier, acquisition, it could mean new accounts, it could be new customers, it could be various other things. So we created that metadata or the synonym list for each variable, so that, which is what helped in sort of bringing that fluidity, that even if the end user is saying something else, the LLM is able to interpret the question in a much more dynamic manner than, say, a much more bounded question that you're giving. And along with that, I think the ability to like have a conversation. So it's not that you're asking just one question. So you can go and build onto that question. You can sort of have that chain of questions. So there are like multiple deep dives that you want to do. Let's say you start with, say, show acquisitions in last 12 months, and then you come down to, okay, show it me for this credit score range, for and these are the demographics, or like then you can go into performance, say, how are these customers performing. So you can have those chain conversation or deep dive conversation, which really helps you to like sort of bring that productivity gain in terms of doing the analysis much faster. And what we've also done is like, again, like we do understand at times you want that audit capability or human in the loop. So you want to understand like how the output is generated. So for that, what we also do is like we give the SQL query out. While the objective is, yeah, it's to democratize. Not every user, the purpose is that they should not be seeing the SQL query to solve for it, but we still give that. So it will sort of explain like what is happening, like for a particular question, what are the variables, what operations are happening, so that the user can see the query, and if needed, they can also edit and like either rerun the query or use it, say, for a different analysis. The query is already there. So we've built that end-to-end tool, and what we've seen is in terms of the early results is in terms of your insight generations are much faster. So we're seeing some of these things can be done 3 to 4x times faster. Your manual work in terms of doing any ad hoc analysis coming, we've seen like almost 60 to 70% time reduction. And like it truly democratized insight generation. So we've sort of released the tool to multiple users who don't really need to really go and do the coding themselves, and they're still able to generate the data and insights. So that's the kind of benefit that we've seen of this. And like there's some improvement areas, obviously, that we believed are still there. And while what we did was, before the tool gets actually released, what we do is like we created, for the validation purpose, like we created like a data set with 1,000 questions and what is the expected output. So we created that source of truth. We validated whether the output being generated by the tool matches with the source of truth. And what we've also done is release the tool for test users, so who may not even know what data is there in the backend. and they're able to query and see like what kind of output and gathered feedback from them to sort of bring that reinforcement learning. Despite that, I think some of the improvement areas that we've highlighted can sort of help the tool to get better. One, obviously, is like we've still not fine-tuned the LLM. To the extent, the major reason was like we had to prioritize whether we should fine-tune the LLM or like we should invest our research and develop more of a knowledge graph, because knowledge graph also took a lot of time. So what we thought is the more critical thing to be done was to develop that knowledge graph. And now when we do fine-tuning of top of this knowledge graph, we believe it will add more value rather than just doing fine-tuning with the data that's there. And obviously, like, so what we do, it's a continuous thing, like the metadata that we're building with synonyms and all. So we'll sort of, as we gather more feedback, we sort of bring in more fluidity in how you can ask questions. And another thing that what we believe can work is coming up with user suggestions. So a lot of times, user might be looking at something different and the tool is not able to answer. It can happen because maybe the data is not integrated and LLM is giving the output, I don't have the answer for this. So we can sort of, on the UI itself, create a page where the user can provide, okay, this is what table or these are the variables that the user is looking for, and then you can create the query from that itself. So these are some of the things I think that we're working on, and I think almost at time, but open for any questions now.
Open for questions.